future, for example, I'm going to do a course on SVN versus Git because I want to talk about it for at least half of a course, because SVN is now very outdated in some areas. The whole world, almost 99% of big companies, everyone is now switching to Git. Because in Vit, especially if more than one person is working on a project or a job, then, merging events and the integration of VT with Bitbucket, Jira, etc. is very good. SVN hangs out alone. SVN has a lot of problems when you try to merge things at the same time. That's why there was a nice graph. I'll find it and show it in the next lesson. I mean, in the world, for example, SVN's usage is falling incredibly. Only such innovation close companies to stay. That's why, for example, and what about me? I came to ASML at 2022. I've never seen anything but VFD. It's all VFD. But I came from 2000. I arrived at 2000 at Daisy's on the 19th. They switched from SVN to VFD. After that, this means that versioning is also very important. Version management. And there should be no duplicates in the library. That is, there should never be more than one of the same similar or the same design. Because, for example, there is a library in SVN, for example. There are 30 of the same VHDL code in that library. Because everyone copied it from someone else and committed it. These need to be clean, and the best one among them should be chosen and kept only in the library. Which, when you reuse it, it's a problem. Problem that was solved in the past, and don't encounter it again. Or don't use a problematic thing, a problematic IP again. Somebody says, for example, the same in the project, okay? Version management is in a project, in a team. But it is similar in every project. Ahmed says to take it from Mahmoud. Mahmoud says take it from Hassan. Hassan says take it from Aisha. It's not clear who uses what. So there is incredible skidding because it's going, for example. Demet has solved a problem in her project. But she starts that project, another project. He doesn't talk to Demet, but by chance he talks to Ahmed. He picks her up. He thinks there's no problem. And he doesn't know that, for example. That problem doesn't arise. There's a mistake. There's an incredible fatal error. Luckily, it doesn't come out for 6 months, for example. He starts to say that the person who bought it is satisfied. I use this one and there is no problem with it. This time everyone starts going to him. However, there was no problem with Demet's solution. When Demet solved it, all of Demet's work remained there. I'm completely shaking the whole thing. On the other side, the other one spread. Such a thing should never be allowed by team leaders, managers, etc. This is the same in software. But software developers are much more multi-people. Because they already work. Because they already work in multiples. They don't happen much anyway. I mean, I haven't seen it. Software developers have better things, libraries. If they are doing it, they are also doing it wrong. But in FPGA design, because FPGA design is more difficult, more time consuming, you are doing a very low level design. Because transistor level, 5 nanometers. A 5 nanometer, you design the transistor. I'll throw it away. Let's say you're working at 400 nanoseconds. You are working at 400 megahertz, sorry. Every time you write 2 registers, is 2.5 nanoseconds apart. Software developers don't care about some details. They let the code go. If it turns in 10 milliseconds, they are happy. How many thousand times more than that? You are doing FPGA design, and you try to meet those requirements. Why don't they have such a problem, by the way? They don't have a problem because of this. First of all, they don't need to be too much real time. One. Secondly, they don't need too much. They are doing something. I mean, they are deliberately making a real time. There is being in real time at the nanosecond level, at a nanosecond level. So your thing there is actually, it's like your resolution. It's like how sensitive you are. They say we do real, the software developer says, for example, I'm talking, but we do it in real time. Everything tells us in real time. I say, how much is your thing? I tell him how sensitive it is. He says, I don't know how much each cycle rotates. He says, but we are doing it in real time. He says, everything we do is real time. Then I ask him how long it takes to learn. He says 10 milliseconds. He says 20 milliseconds. Well, here we are trying to do something in nanoseconds. I mean, a nanosecond is a fraction of a millisecond. A million times over, guys. So nanomicro. So it's a million times more precise. The man also realizes himself, the kid doesn't know. Okay, the kid has no bad intentions actually, but he thinks he's working in real time, for example. That's why. Software developers don't have much to do with delay. They don't worry about it. For example, the highest gigahertz. How many gigahertz? 10 gigahertz processor, 20 gigahertz, and it already has a lot of cores. There's something going on there. He doesn't care about that. He cares about which is suitable for requirements, so in accordance with its own software requirements, the software to do the relevant work. But delays are not a thing. Anyway, when you go to a DDR and back, there is already an incredible delay. 300 milliseconds, 500 milliseconds, whatever it is, depending on the speed of the DDR, the interface, depending on how many interfaces are accessing that DDR at the same time. So these numbers change a lot. To summarize, and what you are doing, your design, let me put my pen back out here. Is that ink space? Wait a minute, not ink space. I'll switch to pen here. Now, just once. You need to reuse. You have to reuse what you've made so you can save time. So don't deliver the project in a year. Deliver it in 3 months, for example. Secondly, the design you make, it has to be reusable. It should be as generic as possible. We will go over them again, those concepts, for those who don't know anything. After that, here are the ports. They have to be of a certain standard. Everyone should be able to, it should be able to connect to those standard interfaces. Here I usually use it for register map. Let me give an example from Xilinx with Oxylite for register map. With Oxylite, for example, registers change your IP. On the other hand, for example, if this is the video IP, here with Oxylite, data in, data out, for example. You know, if you go and make it like this, if you make weird and weird ports, it can't speak in any environmental science. Or if it's a custom design and it's not compatible with, because it is not compatible with custom designs, and it can't work directly. You have to throw a lot of wrappers in between, intermediate code. And that's like, it's called glue logic, for example. It directly reduces the quality of the design. It reduces timing performance. It uses resources for nothing. So as much as possible in your implementation over there. It's like quality designs. I've already created them for you at work. Your team leaders and responsible. Other experienced engineers will choose. You need to reuse. And you have to reuse. Your outputs must be reusable. This is 4. So here now you've done the thing. You've realized the design at a certain level. You have realized it. Already, for example, according to the simulation results, you go back. This is how I finished here. Okay. Now simulation and verification. You're welcome. It's a very big world. So this place is very important. You already know about simulation. It does the design thing at first. Let's say it designs VHDL. It has its own, it makes a simple test bench. First of all, he looks to see if I'm compiling it. Here he connects a clock. He connects a reset. He looks at the basic functions. I'm fulfilling the basic functions. That's the most basic. That's the simulation part. Now, when you say simulation and verification, you are already entering a completely different world. They're already, here the system is no longer given. It comes to the forefront because it has very good features. I'll tell you about them. But here too, here code coverage and functional coverage, there are 2 basic concepts. So one of them is CC, code coverage. The other is FC. For example, I know this. Every year, maybe millions of dollars, there are already things like Model Sim, Questa Sim. They have, for example, it's a great way with very little effort that can solve the problems of your design code coverage feature without even being activated. It's been around for years, guys. I know a lot of things. And this is just at work. In one defense industry company, it's not something that happens or a part of it. I mean, I've talked to so many different defense industry FPGA designer I've talked to. It's good that things like this are happening. There are meetings. You can attend them. And for example, I don't know, MATLAB is doing something. There used to be technology days. Arrow, for example. I'm sure they're still going on. You can join them. There you'd meet engineers from different networking, points of view. You know, with them, you know, to have a technical conversation or just social conversations. I'm trying to get involved. And I talk to a lot of people there. I still do. They write to me on LinkedIn. Sometimes they ask for advice. I ask them something. But neither code coverage, neither functional coverage, they don't use it properly. I've used it in DAYS and ESML. This code coverage and functional coverage, I know that they are used very well. And these are constantly reported. And about that, Ali is my friend from here. He knows these things better than me. I know code coverage, by the way. I know code coverage. And I can do it well, but functional coverage better. I'm not that good because functional coverage, given a system, you must know it very well. And there's UVM, that is Universal Verification Methodology. You need to be good at it. For that, a regression training, Ali will give it to him. He'll explain it to Ali in one of our classes in the coming weeks. And again, in his question and answer session, we'll already be side by side in class. Ali will come to me. We'll do it in this environment, side by side in class. And in the question and answer session, even if she can't come, she'll still participate with the voice. You can do question and answer there as well. The output here is actually simulated and verified. Design. Now, if you don't have a verification engineer, wait a minute. Let me take that back because I crossed it out. At least you don't have a VHDL and there's no extra verifier. Okay, on your team. At least you guys, you need to write self-checking test benches. It's automatically like this. It checks your design, and it's not that hard to write. Any of these FPGA designer can write, and most of them don't know about it. Self-checking test benches. And there are some who do, by the way. I'm not saying there's no one who knows. I'm talking about the majority. It's not used. Self-checking test benches. Actually, you open this. You don't even need to open Modal Sim. It's right in the... What's it called? A mod. It's not GUI mod. The other mod. I didn't think of that. You open it with -v. It's extra, no GUI. Think of it like batch mod. Coesta calls it something else. It's not batch mod. And anyway, think of it like batch mod. The tool doesn't actually open. It's just you're in something while the tool is spinning in the back. At the same time, you can also put prints. You can put them like this. With, what is it called? You can't put into VHDL that print stuff. You can embed it, commands. After that, it had a name. I can't think of it right now. It's not very critical. I'll tell you about it in the future. If you think of that thing over there, I'll open again. I'll do it from there. Musa said comment line. Wait a minute. He went here. That's nonsense. I'll move this to the left. You open the comment line interface with the minus thing. Normally, if you type in qsim, or what was it? Was it vsim? Vsim command, I think. It opens directly in batch. Is the sound a little low? Let me get closer to the microphone. Is it better now? I'm closer to the microphone. A friend wrote that the sound was bad. It should be better now. I'm closer to the microphone. Batch. It's much more happening. And I was saying, by the way, VHDL. This thing has a name. I can't think of it. This report statement or something. What's it called? They have severity, warning, and then error, note or something. That's something in VHDL. It's a section. I didn't think of it for a moment. Assertions. Now I found it. So that says the sound is fine now. Now, for example, using assertions in that batch mode. So when it flows in comment line, your thing. Comment line interface, you can print it with print. Like this, completely in batch mode. You do not break away from the thing. For example, it prints pass, 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 or pass. After that, when it gives an error, you can exit directly. Failure from the comment line. That again depends on the severity of assertions. I mean, here it changes according to the level. According to the level of the error. For example, if you say fatal pat comes out of batch mod, for example. But if you say warning, it says warning. So that's how it is on that self-checking test bench. That's the eye and the signals. Is it in the right place at the right moment? Is it putting out the right output? You don't do any verification from the waveform or anything. So it's much faster. For example, I took a course from Doulos. I was only a one-year engineer at the time. I wish that training, for example, if I had been trained by the experienced people inside had trained me from that Doulos comprehensive VHDL and an expert VHDL. I wish I had gotten the training like Burak. When I was a 3-5 year engineer like Burak, because in 2011 there was a guy named Alan Fitch, a very solid VHDL teacher, guru. I mean, the guy, when we got, this is comprehensive VHDL and expert VHDL, he was just then That was in 2011. How many years has it been? 2011. 13 years. And you can feel that the guy, he's been doing it for like 10 years. He's so experienced. I mean, the guy runs everything on a crammed basis. Exactly what? He wasn't in Viva at the time. Well, there was, I forgot the name of the tool. I used it for years. What was wrong with Xilinx? It had stock, IC, Xilinx, IC, and here's Quartus. They had them back then in 2011. The guy would never open their GUI, for example. Only when there was a problem and he needed to look at something detailed. And he needed to look at something in detail. All the code, it was script-based. Adam was running the script. All the self-checking tests were running. The compilations were starting, everything was fully automated, for example, his whole flow. And when you talk to the guy, already, your man, you realize he's been doing this for years. He's left Doulos now. I have a connection on LinkedIn. With him, he's not very active on LinkedIn, but he's in another consulting company now, again in England. I mean, everyone already knows these things. I mean, people have known for years. I arrived at 2020. These are very useful features of code coverage. I will explain them in the content of this training. I explained them and so on. They are all exported to a file called UCDB. UCDB is a universal coverage database. Extended document. When you open coverage or code coverage, either and Questa. This document is automatically generated and the results of coverage results are in this document. It starts to be saved. You can also export there. You can also export the reports. For example, I told you about one in 2020. That team already, some of it's gone. After I left, there were others. And those who didn't leave still don't use code coverage. Neither code coverage nor functional coverage, for example. A separate verification team was created. It was established. But they also have this, it's related to other jobs, in avionic jobs, because this verification is much more important. There was an incredible workload related to them. I mean, non-avionic. It's about electronic designs. Any person, for example, code coverage or functional coverage. Is it used? I don't know. I don't think so. Because I've never heard of it. A few people told me, code coverage is a great thing and our license has been for years. Model Sim has this. They said it was very good, but I never found a bug like this. Thanks to this, I found such a bug. I found a bug like that. I mean, I've seen two, except Aselsan, in big companies, both code coverage and functional coverage, the results are reported weekly and you get an email every week. This much is at this level. This much is at this level. Here is code coverage below 95%. It's not wanted. Below that, if it is, you get a message to raise it. Functional coverage is already what they want functionally. Verification software developer, that's what they write together. All the written requirements, because it needs to be verified. It already needs to be 100%. And the ones that are not 100% are already verification engineers. That's where I am now. I've moved in that direction. I mean, my trainings and stuff. It's almost over. Slowly, I'm going to start getting a task. It's like this very quickly. Come on, you come tomorrow as a verifier. It's not like you just start. Verifiers. If the functional coverage is not full, they try to make it full. But here, of course, FC for in that planning over there, the requirements are very important. If you don't have these requirements, you can't do a functional coverage. Because accordingly, you connect the tools together and you do functional coverage. I saw one of Murat's questions. What does wants mean? Requirement means something. Your requirement, it's also in English, from your design. The things that are required. What does it have to achieve? This design will get these inputs. In the end, it will create these inputs. It will create outputs. Or it will take a video like this. From that video, it's going to output a video. A video will come in, a sensor information will come. According to that, it will do this and that. What is required of you at the basic level of design? That's what it wants. Now we're at 5. Resource and timing optimization. This is also very long again. I could talk about each of these steps in 10 hours. I can talk for 10 hours. I could talk for 80 hours in total. But let's not drag it out. Then you know it's not being watched. And I don't want to take up any more of your time on Sunday. We've reached the end of 2 hours. I'll finish in 7 or 8. Every class now. Every class for the rest of the weeks, especially. I'm going to talk about things for 3 and onwards. About documentation. I'm not going to tell you anything in detail. You already know how to do it according to the company. You have to learn how to do it according to the company. We've explained 1, 2. This is again very person and it depends on the requirements. It depends on the team. But 3, 4, 5, 6, and about 7, right in between 5. That's 5, right? Exactly. It's about 3, 5 parts. That's what the training will be about. Resource and timing optimization. Actually, it's in the syllabus for the 4th and 5th week. So there is. Here I want you to optimization of both the resource consumption of the FPGA at maximum speeds, at maximum frequencies, at maximum speeds. Optimization, you need to do it, and you need to optimize. In constraint files, here's XDX, Xilinx, design constraints. Here are the other, for those outside Xilinx. By the way, Xilinx's XDX, SDX's, it's becoming, covering, I think they're going superset on it, so it's covering it. There's just some extra features that are Xilinx specific. But most of the SDC, most of the things, SDC constraint file. So what SDC actually becomes is Synopsys design constraints. Synopsys at the time made a standard about it. And then the other, well, he took these. There used to be Actel. Actel used to use Actel, SDEX. Actel also had a different file, his own, by the way. But here's the thing. Intel, Altera used SDX for years. Be careful with them too. You know, for example, Xilinx has some SDX, but I'm sorry, Intel's, some SDX commands are only Intel specific. So you can't just go and use that supports another SDX that changes the Synopsys design constraints file. That changes the Synopsys design constraints file. Vendor, the commands of that constraint file may not work. Fully constraint design. This is very important. When your compilation is finished, all input-output ports. So these are now the input and output. Tool doesn't know anything. These are synchronous. They come in synchronously, inputs. And when it comes out, when it enters a chip, what you're outputting or what's coming in from the outside world, will it synchronize to another clone? He doesn't know that. All the input-output constraints must be given. Any timing violation shouldn't be there anyway. Warning may be in your design, but critical warning, absolutely not. We'll go over them and stuff like that. And for example, the thing reports it very well. Quartus, you can see it a little bit more in Xilinx. One more click. You need to go into more detail. Open timing analyzer. For example, it says if all your constraints are complete, once when you open Quartus, it's never red like this. You don't see any red. You don't see any fonts. After placement and routing, after compilation, everything is like this. It's a light color. And at the end of the compilation, whether you work in bash mode or GUI mode, I don't recommend you to work in GUI mode. I'll explain them in the future. Because both in GUI mode, it takes longer. It takes longer. And, well, you can't. What can I tell you? You get too caught up in the features of the GUI, and you get used to the GUI. This time on the server like this. On the server as it should normally be. When you run these things, you normally press the power button on your own computer. These compilations shouldn't be running. You can't just put some streams on your own computer and upload them to the device. Then they can be buggy. And but luckily he's in that compilation. Everything is beautifully produced, and you think the design works. They are so incredible. Sometimes 3 months, 5 months, 6 months, it causes labor losses. Optimized resource usage and timing performance. I'm going to talk about this already. This is also very important. Design and code review. This is optional step as Sinem added. Here, conceptual design review, somewhere over there. If you find time, by throwing a meeting, Gene, you can have a design code review. When you look at me like this, the best place for these 8, resource and timing optimization, if you'd like an opinion after you've done that, a 2-hour meeting. And the output of that is review design. This also happens to be manual is what I call a review by your teammates. Review. Automatic is HTML. Designer has design checker, for example. Or there are programs for other equivalent tools. They will help you again, the code, and it automatically makes you do some reviews. You enter some rule sets into them. Linting is also in there. Then there are some extra things that can affect the results of the design. It can affect the mapping to hardware. That can affect the mapping to the hardware. It scans them automatically. It gives you a score, for example. Accordingly, if your score here is low, you go back and fix it. So you actually go back to the thing. You go back to implementation, you fix them, and then again, you run simulation, verification, resource optimization, for example. That new code you just made, if you think you have already resource and timing optimized, you can quickly skip this place. You can, of course, check that timing is holding. This place doesn't take long then. Then review is also done. Actually, what's the benefit of that? It's a very important benefit. Your design is now less problem-free. It's less problematic. I'm sorry. So ideally, problems are identified. Not all problems are solved in code review. The designer wants you to exactly what you're implementing, so he can't know in detail. He sees the basic problems. Experienced people see them very quickly. For example, I am doing code review right now. I used to do it in 2 hours. Now I do it in 15 minutes. I know where to look directly. Then, if necessary, I can quickly make I do placement and routing only for OIP. I see if there are bottlenecks, etc. These are a bit of experience, but if you start doing that from a young age, if you start participating from a young age, you learn much faster. What happens? The reusability increases. This code, and it's a transfer of knowledge. Know-how is also transferred. 7, regression, qualification, and system integration. In this section, for example, right now, the regression part was very good. Barak Dursun is my friend. I gave him a regression. He was doing VHDL-based regression very well. I'll tell you about him. I'll ask him. He'll give the lecture. I talked to him. For now, if nothing goes wrong, he will give it. Ali is also very good at regression. Ali will explain it too. Qualification means that the IP you've designed, and test it yourself. It's like pre-qualification after system integration, integrating it into the system and testing it. Now, if you do these first 6 steps, if you've already done the first 6 steps, and give it to the system guy. I shouldn't call it a systematician, but systematician is not a very correct concept. I should say tester, integration into the system, but the test engineer, if you give this product and anyway, sometimes in the module unit, they do the tests. Sometimes they also do it in the thing unit. They also do it in the system unit. Or when there's already the possibility of problems here, much better quality. Of course, there are problems. Sometimes there are problems with the algorithm. Problems arise. There's a problem with the software and the hardware. There are problems with the sensor. So there are always problems. If you want a life, you shouldn't be an engineer anyway. The road, I'd say, do it, in engineering, I'll work during the day, that day, solve all the problems that day. I wish it were so, but it's not so. A banker is appointed, a banker, for example, he does all his transactions that day. His working hours are over. His problems for that day are over. And even some of his problems, they are left for the next day. But in our work, it's usually more long-term challenges. It's a lot because sensors, too many algorithms, too many units talking to each other. So it's a difficult world. It's not an easy world. So if you don't like these kinds of challenges, and you're currently studying electronics or computers, I'm in electronics or computer science, and you're doing very well, in economics. I have friends who have had very good careers in, economics. If that doesn't interest you, which I'm very interested in, I'll go on about it again. I love it. But for some people, it might not interest them. So you can change it. It's not like you're going to stay around here. And don't be afraid that you'll see these things. I can show you the big picture. When it's actually done right, how complex and how high quality, what a quality product for humanity, So this regression, qualification, systemic integration, some of my friends will also talk about this, and I will talk about it a little bit in the remaining weeks. And the output of this, actually, there you go, this regression tests. What exactly is regression? What's the full Turkish? Let's see. What if it's like a stress test or something? But regression is exactly, it's not, it wasn't regression, for example, on Google Maps, and it says regression. Let's write what regression means, or Ali and I can explain this. And already, Burak said regression analysis, the relationship between two or more, to measure the relationship between two or more quantitative variables. So you can take a look. I mean, regression is a bit like regression actually, with all these different inputs, with different variables, with different scenarios to test your design thoroughly. It's actually one click ahead of simulation. But I've already done simulation verification. Here is a simulated and a design that has already been simulated and validated. It's much easier than integration. Let me tell you that. Again, if I'm wrong, Burak and Ali will correct me. Qualification has the thing. In the case of your unit, the designer has to make a design himself. He's going to test it, for example. He's got sensors, demo boards. He has a custom board. He qualifies them, puts them through certain tests. And then here is actually the test engineers in the system integration part usually. And they'll first have a test engineer do unit testing. They also have a very nice, they prepare the infrastructure. That's a very valuable job, by the way. If you enjoy it, you can also do test engineering. A friend asked me in the past, there is no design position, test engineer position. If I become a tester, can I be a software developer in the future? Can I be an FPGA designer, verifier? You can be. I have a lot of friends who started out as testers. I have many friends in the past. I say a lot, 5 or 6, not that many of them, by the way, at least more than one example. And by the way, he started the test and then he loved the test and stayed on the test. And I have 5 or 6 friends like that who took the test. So that's pretty cool too. But I don't really like this direct systems engineering. I don't like it very much. I mean, they hire a 1-year engineer as a systems engineer, as a system engineer. Then they make the kids run around. Lava, go tie them up. Lava, go connect these. Go test the system. I don't know. It's a little bit like something like an integrator. It's like an integrator, but integrators are actually very good design. There are integrators that do verification, and they write Python code like this and test the system. In our defense industry, the system engineer I've seen, I don't see any equivalent in Europe. We have Architectler here, for example. A man, an engineer of 10 years, an engineer of 20 years, or in 5 years, as in 5 years. They made him a junior architect, like a man or a woman. So, you know, I'm not suggesting you go straight into systems engineering, but of course the choice is yours. I'm talking about the definition in Turkey. Then this system integration, actually we can also call it, by the way, it might be better if I change it like that. That's it. Unit qualification, then system qualification, Shishan or system integration. That's how it's combined and qualified. Excuse me. And then at the end of that, in regression testing, there's also simulation. Here it is again. It's not just tests that have to go to the lab. They should go to the qualification lab. But with regression, again, for example, here in the software, you can make a loop. You can also include the software. For example, you have a microblaze. You have a microblaze running. You can bring C code, C++ code into the test. Or there's something running in external memory, something that runs in external memory. Embedded Linux, for example. You can include that too. The levels of those tests vary a lot. But here's what civil means. A loop in your software. And civil means a loop in hardware. So that's how we simulation with Ethernet and ports, things, optical cables to your computer. And then, again, taking input from the hardware. you can do regression in the loop in the hardware. There are different levels of these levels. The other qualification system, I mentioned integration. I'll say one sentence in documentation. When you have already done these 7 steps well, it is so easy to write documents. For example, we have people that don't want to write documents, but already because they're missing these steps, so they can't write a document, and that's why they don't want to write. Because if you do these steps well, like let's say you've worked for 6 months, let's say this is IP, and you have integrated it at work, tested it. Now it's in the system. It works very well without any problems. It receives inputs and gives outputs. It takes 3 days to write this document, friends, 2 days. Because you have so many outputs here. Intermediate outputs. I wrote something here. Design documents extremely benefits from the output of first 7 steps. Now there's another one. And I'll show you something else. This is also important. Let's go to the second slide. I couldn't. That one. Now this is also very important. This is also very wrong, for example, in Turkey as I see it. Now for one thing, even those who don't use a task management tool, and then there are too many teams. First of all, that's already a very fatal situation. It shouldn't be there. But the task management tool, because you are using it, that doesn't mean you're using it effectively. I mean, you're using, say, Jira, or I don't know, there are other things. There are also task management tools. For example, we used to use Kanboard. We switched to Kanboard at Aselsan. That's free too. Toyota's, something from Toyota, told me. I saw it from this software developer. It's just for free. And it's very easy to install. Let's use this. That's what he said. IT took care of that right away. We, for example. Is that an image of Kanboard, okay? On Kanboard, there's a task open. Now, this is very important. A project has come to you. You definitely want it to have its task written down in writing somewhere. You can't make a task. No task can be done by mail, guys, okay? When I say emailing. Outlook had a feature. Our old manager, my old staff used that for a while. It was okay, but, assigning tasks, task assignment from Outlook. That's nothing, is an alternative to not using it. But the best one is Jira, for example. I didn't have enough time to put a Jira output here. But here I'm trying to show you task. Tell your team leader, write me the task, define the task, and write down the requirements, or direct me to the document with the requirements. If you don't request that, okay, most of the time you're so busy, you'll get something verbal like that, and you skid. That shouldn't happen. Now this task management tool, let's say Jira, okay? Project A has this task, task 1. Here will be the name of the design task. And the breakdown of the task here, okay? For example, here, planning, concept design, implementation, simulation, optimization, testing, review, documentation. I've divided it up, okay? The design subtask is right here. If you don't do this, you're saying, someone comes to you, there's a wheel here, use the wheel. And this guy here says, no thanks, we are busy. He says, we are very busy. You go ahead, pull it like this. If you could just put this wheel on, you get the joke. I mean, it's going to be a lot faster. There's a lot of that. I've been in this situation so many times, I can't tell you how many times. And this, by the way, these people you work with, about the people you work with, it just means that they're the big picture. Those people, they can still be very smart, they can still be very successful. But what they could do in 1 year, they can do in 5 years. It happened to me too. And that's what I did once. That's why I'm telling you, I can customize. I went to Germany. I've been an engineer for 8 years. 3 years as an engineer. He's much better than me. Much better than me. Now Jira is being used. Musa said something. Jira in the software world. Wait a minute, I couldn't read the other one. That heart of his is right there. Why can't I move it like this? That's what I hate about this thing. They use tools like Notion, he said. There are a lot of tools. But for example, the same mistake is made in the software world. For example, I've seen software developers, okay? Task is defined. But there's absolutely no subtasks don't exist and are not updated. Here, for example, I can show you. Let me tell you what's different here and in Germany. Task management tools are used and your team leader is on it all the time. He goes over it every other day, okay? He's looking at it. And then at the weekly meeting of this project, to you, looking at what you've written, looking and guides you if necessary. You've wasted a lot of time here. Go to that one. Or you didn't do this one very well. Go to this one. You know what I mean? Don't think of it as micromanagement. Sometimes it can open incredible doors for you. Anyway, if he's wrong, you talk to the guy, you convince him. You know what I mean? For example, we have a lot of tasks in Jira right now. And now we've moved on, what's that called? Sprint-based. It's not. And Kanban board, not Kanban board, but we've started using these sprints now. We're doing 3-week sprints for FPGA designs and verifications. We go over them every week. The manager's already going over it. He's my manager, a team manager of 15 people. There's also a team leader, but the one I work for in the project, the most experienced man on the project, and he's going over it. He's looking at it after that. So what I'm trying to say is that this task management tool of their and other tools integrated with it. In the task management tool, for example, SVN, let's say you connect SVN to Jira, connect SVN. How do you do that? It's probably going to be some bullshit. When you use Git, all the stuff in Git of the committees, as soon as you enter this task number, it just pops up on Bitbucket, okay? On Bitbucket, you already see everything. The guy opens it from Bitbucket, straight from Bitbucket. He sees all the committees, he sees all the details, and then you tell Jira, you've already written here under the task. So that's why I think that's pretty awesome right there. Maybe there are better tools, I don't know. Go to Bitbucket to Jira integration and Confluence integration. Confluence, because you can make drawings and you can make documents and stuff like that. For example, they don't use Confluence here in ESML, but they were using Confluence because they were also doing the documentation in Confluence because Daisy. But I can tell you this for sure. Go Jira and Bitbucket. It's a pretty unbeatable trio. And then you connect them to, that's what IT does now. IT support does it. And then you connect them to a server. They're already backed up, and you through Bitbucket. That's where the builds are happening. And anyway, because you come from those steps, you know that thing, so you know not to use the GUI too much. By the way, you can open the GUI again. I mean, you copy something done on the server, for example, to your computer if necessary. You can open and analyze all the files. You can open the files and analyze them in detail. But normally, unless there's a big problem, you look directly from the server. You don't just copy something to your computer and open it and look at it again. So everything that is built on the server. The thing is, and when you go like this, so go Bitbucket, Jira, what I've seen so far, and it was like that at ASML, for example, and Daisy. They also use Confluence there. For documentation, ASML has its own documentation system. It has an infrastructure. We do it there. So this is happening. It's an incredible, it gives you something. Actually, it does. I'll put it this way. Go to Bitbucket. You'll have a good team. Go use it. Use Bitbucket. Use Jira. Have a good team leader. 6 people can do what 30 people. That 30 people can't do in 5 years. 6 of you can do it in 1 year, my friends. Let me tell you about such a labor thing. Because you are incredibly planned and programmed. And let me tell you this. Those 30 people, let me put it this way. 30 people, I'm giving these examples. 30 people looking at 30 projects, 30 FPGA projects. 15 of them will be maintenance and 15 of them new projects. 30 people looking at 30 projects. And let's say they finish it in 5 years. They shouldn't use the thing. They should use SVN, or don't use at all. Just keep it on the server, on Linux or something. Just back it up. Or Windows has a backup system. When you turn on your IT, when you connect it to the server, 30 people, 30 projects to run that 5 years. I say again, 30 projects. You should have 6 people. In 1 year, they'll do the same thing. You've got a good team leader, a good 6-man. The team, and this go Bitbucket. Plus, what was that? Jira. Let him use this trio. The other 30 people that you don't use this one. And the team leader, let's say there are 3 team leaders. 10. They don't have too much with each other interaction. All right. Everybody focus on their own project. Focus on their own team's projects. It happens because I've been through it. I've seen them. The same work they can do in 5 years. 6 people can do it in 1 year. I'm very ambitious. How many times is that? 150 unit, 30 times 5 years, 150 units. The other one, 6 times 1, 6. So, 35, 25 times more. That's my rough calculation. So for someone starting a company, for someone who's going to start a company, or for someone who's already the manager, director of big companies, is getting work done. So he should think about it from that point of view. He earns 25 times. And he doesn't work at all, for example. They think like this. These people, 30 of them, I'll make them work overtime. I'll make them work 11 hours. And then on the weekend, one day on the weekend. So these 30 people will do a great job. No, I mean, these 30 persons, you put them on overtime. I told you. I've calculated a rough ratio of 25 to 1. 5 days a week. And bring him in on the weekend, all right? 25 to 1, that's what I said. It'll be twice as bad. 50 to 1, that he'll work more efficiently, because as soon as people are forced to work overtime, they start to reject all innovations, because they say that I can't do this. They don't touch the maintenance projects directly, for example. Okay? Chuckles. And if it didn't feel good, it probably didn't feel good from the past, because these concepts didn't exist. So what do they do then? 20 years ago in most companies. First of all, the employees, they definitely don't touch the old ones. There's a saying that they don't touch the employees. The employee explodes at some point. They don't work all the time. Anyway, if he worked all the time, those projects would never be touched. Anyway, the project, if it's working 100%, freeze that project anyway. You don't want it to be, or anything like that. But of course, it happens. They give him someone. When there's a problem, because somebody comes, okay? So those projects are not perfect. So they're not projects that you freeze. There are some problems, you know, when they're going to come out, and in what scenario, I don't know, which features of that design is not known, because there is no detailed documentation. It's using something, but what is it using? It's like all of a sudden it turns on a feature, like bam, everything explodes, the whole pipe collapses, for example. So I'm just saying, you can't call them. So for example, if there's a friend, if he's listening, you tell people you can push for 8 hours of productive work, 8 hours a day. All right, you're paying them, you pay them, but you give these people 7 hours out of 8 hours, 6.5 hours. Say, for example, work. Don't play with your phone, with your social life. You know, don't look at the media, and you know, by doing things, develop team spirit. For them, of course, you'll support them for that team spirit, to be good. You'll tell them to work. Okay. Everyone agrees to that. They'll learn the most, and you're going to, as the founder of the startup, as a founder, and you'll make money. That's good. But you're going to put in 11 hours, 15 hours, 16 hours a week, okay? I mean a day. And when you start working 50 hours, 60 hours a week, once these people, they become close to innovation, they don't want innovation anymore. And gradually their social life starts to end. Their social life is over, and then some of them get burnout. Some of them get disenchanted with engineering. They get disenchanted with electronics. They say, I'm going to be a software developer. I've had enough of this. I've been doing this for 10 years. So in the long run, you're losing these valuable people. By the way, the same for the directors in the defense industry. To the directors in the defense industry, I'm giving this advice because this has happened a lot around here. I was very demotivated most of the time. Somehow, because I am a self-motivated person, I picked it up, I recovered, I went back to work. But, you know, these people, you have to do something with these people. You know, they have to be for the company, and on top of that, for the country, that you use it in the most efficient way. That's why you have this responsibility. That's why you are managers. That's why you're managers, directors. That's why, you know, those things, positions, if you don't want to, okay? Anyway, I know there's a lot of pressure from above. From the right, from the left, you are subjected to a lot of pressure, but no one tells you that you have to become a manager. They accept being a manager. They accept being a director. Fine, be one. It's your right. You've been offered that. But I mean, if you can't protect your staff when you're under pressure from above, you can't, 11 hours, 15 hours, you know, okay, once, twice a week, or a very important period of a month. Or for example, when I was at Asalpod. This is Barış Düzgün. Right now he's the CEO of AssistCard. Barış Abi, for example, he took us for 3 months. We'll be working overtime. We're going to stay for the whole ETM, for example. Sorry, I think it was the whole Asalpod team. Then we were crowded like this. There were about 20 of us, 20 or 30 of us. We stayed for 3 months, okay? Only in case of an emergency or something when there was an emergency or something important, you had to go and get permission then from the manager or Barış Abi. Nobody said anything, okay? I've never heard anyone complain like that, because that period was very critical, okay? And these three, the moon, Brother Barry's Hasselpod's thing, during the period project technical manager, I think it was like that for about 4 years when I was working with him. This happened once, okay? And that was a very critical period. At that time, everybody, okay. But you guys, you make it a habit that every time something doesn't work, stay late, we'll arrange a ride on the weekend. I'll tell you it. Then it's not Saturday or Sunday when you get into these balls. That's when people know what they're training or what they're doing. They put their hands to the grindstone because you don't want people, the moment there's a problem, you give them the thing that makes them work overtime. You know what I mean? Even if you start not doing it in the meantime, if you make it a habit, people are afraid that you're going to do it, and they're afraid you're going to do it. So I think now, for example, very close friends of mine have become managers. That's my advice to them. And here I'd like to invite, if there is, I'll tell you. For example, the most valuable thing I think you have for 10 years, 15 years, to be able to say, well, that's what I say about Barry Sabi, for example. I mean, the man, it's hard. When the pressure came to him from above, he stood by us through the hard times. Okay? So that's very important. You need to be able to do that. If you can't do that, then you shouldn't aspire to those positions. Yeah? If you have, and you have to quit. If you can't, you know, if you're gonna act like an all-pass filter, about, or you, for example, a CEO, a startup, if you're the CEO of the company, and you're going to treat these people like this, you have to be an engineer somewhere. You have to be a designer. You know what I mean? Anyway, when you're a CEO and you're a founder, many other parameters come into play. It's the fear of failure, the fear of not being able to rise, not being able to grow. You know, being an entrepreneur is a difficult thing. Being an entrepreneur, no one claims it's easy, but you have to minimize these negativities. You need to reflect these negativities to your staff at a minimum. You know, it's not just the people, the country of the country, and act accordingly. That's all I have to offer. That's all for this class. I'm sorry it's been a bit long, but let me go over the questions quickly. Let me do myself full screen. And I'm trying to look at the camera. I'll try to make a little eye contact. Let's turn this off first. Let's turn this off. Let's close PowerPoint. Let's move OBS to the left. I'm full screen. Don't glare your glasses. Let me take your glasses off. Over there, I'm going to go through the YouTube questions of the YouTube questions. I'm just looking at the questions. If you write clean code, you won't need to write a comment. I don't agree with that, Musa. Even if you write a clean code, I always need to write comments. Because when someone takes that code into the circuit, we'll go over it. I'll explain it in the linting section 2 weeks from now. Wednesday, Yilmaz Erin, whom I love very much, he's one of my friends. I asked him if he could briefly talk about the code review process. He said. But he said it at an early hour. I think I did, Erin. That's why I'm skipping this. If there's something I don't understand about code review, ask me again. Do you use EHLS? What do you think about the future of this technology? Now, we don't use EHLs. And frankly, I'm not very positive about the future of EHLs. Why not? I don't see this screen share. Hold on a second. Right now, you guys are... What do you see? You see me? I can do this then. I can move this over here. And I can move this to the left like this. Now you can just... I dropped it now. It's like this. I'm going to read it directly from there, across. We don't use EHLS. I don't think the future of EHLS... I don't think so. Why don't I think so? When did we get it? We got a very good training on EHLS from Xilinx. At that time, Xilinx had not switched to AMD. One guy came in. I'm still influential on LinkedIn. He's now an AI guy. He's an expert now. He moved to the AI side of Xilinx. He's pretty solid. Harvard, something like that. I don't remember his last name. He gave us a very good EHLS training, for example. He gave us a daily. You came to Aselson. I don't think the future of EHLs is not very much 2015-16, something like that. That's when I realized it. Because, I mean, to use the EHLS effectively, you have to have a very good, you need to know FPGA design, and you need to know very good software. All time pragmas were entered. It was a C-based system then. I don't know if there is C++ support now. EHLS. But do you know what the guy did? He made us a design from scratch, but he started from scratch as if he didn't know anything. He started like this. He finished one design all day long, and all the phases of all 10 of his phases are registered, okay? So someone from Xilinx did that design. He did one thing. He designed something cool. He designed a filter, an image processing filter. It's got all these different filtering stages and so on. I don't remember the details now, but it was pretty cool. But you can write that code in C with at work. To the EHL's tool, the high-level synthesis tool, to get it to print to the high-level synthesis tool, you have to enter so many pragmas, you're interfering with the tool, which you need to know very good software, and you need to know hardware very well. If such an engineer, anyway, he has nothing to do with EHLs, you know what I mean? He can do better himself, sell the IP or something. I don't know. For example, I worked for 3 companies, all 3 of them, world-renowned companies, and my teams were always very good. They were very good people. I was in one of them who knows software very well and knows hardware very well, and very good hardware. At a certain level, maybe he knew someone better. Not in the team, by the way, but in their company. In the whole company, because there are meetings and you talk and stuff, because he specializes in one. Okay, he has software knowledge. He's an FPGA guy. He has hardware knowledge. He's an FPGA guy, but a very in-depth, a lot of project experience received. So there's no possibility of having both. It's not like you can give everything to one person, because then you give that person a lot of responsibility. And if that person leaves, and the project suffers a lot in the team, because there goes the know-how. Because there's no time to transfer that know-how, And so suddenly both the software and the hardware is going, I mean, think of it as a project. There are also personal preference reasons why this doesn't happen. For example, the man likes software more. He specializes in software. He likes hardware more. He specializes in hardware. Excuse me. And using HLS effectively, you need to know both very well. That's why I don't see much future. I don't see much future in HLS. I don't know. Maybe I'm wrong. Mr. Burak said there are a lot of online interview experience videos on software. There must be. I mean, we could do an FPGA, like an FPGA version or something in the future. Or we could do something. We could have a lottery. For example, every week someone will be in the draw. I could give him a special, as if he was taking an FPGA interview, something like that. We can do it as a gift or something. But these things always take time. And I've been, in the last month, I've been incredibly tired. So I'm going to learn the tools. I'm going to learn OBS. I'm going to learn this YouTube studio. I'm going to prepare the infrastructure. I'm going to prepare the training content. Do you think that's enough time? If I could devote full time to this, I would do so many things. But full time? Not full time, unfortunately. It's difficult to enrich the content too much. So for now, 1 week lecture for FPGA, 1 week of question and answer. Let's skip it. Let's finish the 14 weeks. Then we'll talk about what we can do. I just saw Fevzeren. I'm sorry about that. I fixed it and then I shrunk it down a little bit, but asked if you could minimize your image a bit. I'll go with this. Did you install the live chat overlay Chrome extension? Did you install it? I haven't. I'm making a note of it, Erkan. I'll try it. I'll copy it from here and add it to my notes. I'll write it down so I won't forget it later. Such a Chrome extension, maybe it could, like I said, without Discord. Our Discord channel, we'll still use our Discord channel anyways for the other features I mentioned. I'm looking for questions. Yeah, I mean, that's what Ahmed said. Actually, that's the swing cartoon. It's what the client wants, and that's what people from other disciplines understand. That's what he said. He said you can use Excalidraw. I'll make a note of that. I'll test that too. Thank you, Bilal. I'll throw that in there. I can test that too. Excalidraw. Unit specification, he said exactly. Unit specification. Any other questions? Verbosing, that's what verboso is called. And then I remembered assertion. So if you type assertion, if you use assertions. Assertion, by the way, is the system in VHDL, in Verilog. And in Verilog, there's a half a day of something that takes 5 days, that takes half a day or something like that. The use of assertions, because you can do a lot of things with assertions. You can do prints. You can use assertions to create some links, fatal errors, and you can make them like this, and or you can use those about the occurrence of those situations. That's a pretty assertion, is a useful concept. That's nice. Moses said, reminds me of a quote by Abraham Lincoln. If you have an hour to cut down a tree, for the first 45 minutes I only know my axe. So it's true. What you can't do in an hour, you can do in 15 minutes with a sharp axe. That's a good one. Thank you. Is it appropriate to leave engineering? Is it appropriate to leave engineering at 35 at the latest? Or stay an engineer? Ahmed said, I don't think so at all. For example, here I work with an engineer at ESML. He's like 50 years old. He's still just designing. He's very happy, and so many things from him. For example, there's no such thing as running away at 35. I don't think so. I think there is. You do what you enjoy. Whatever makes economic sense for you, you do that. I mean, that doesn't make sense either. Like, for example, you're not making any money at FBC. Okay? Get a job opportunity. You're not getting accepted for jobs. You can't do anything. And then, because you love it so much, design the FBC. I mean, that world. Sometimes circumstances can push you into something else. To become a software developer, to be a software developer, or to be a manager, that's in a person's private life. You don't know the details of that. If you ask, he'll tell you, if you're on good terms. And everyone doesn't have to tell everyone. But I don't think there's such a thing as running away. For example, I don't think about running away. I'm 37. If I have a lifetime, I'll continue in design. Now, for example, 12, 13 years design. I want to do at least another 12, 13 years. In at least another 12, 13 years. But I also love, for example, I love teaching and as an advisor to solve other teams' problems. They call it technical advisor and trainer, technical trainer. For example, if there is such an opportunity, maybe I can switch to that in the future. I'm speaking personally. I mean, run away from design and become a manager like this. I don't have to think about these things anymore. I don't want to think about these things anymore. Are there any more questions? Tevzi said, my teacher said, that we can use with the lectures, or that you recommend. I will recommend them. Now, this first lesson, I actually told you about that flow. After that, we had a question and answer session, and I have no energy left. Doing something for an hour. How long have we been on the air? It must have been a while. How long has it been? Let me see. It's been 2.5 hours again. I'll split it up a bit, piece by piece. I'll upload it after I record the live broadcast so that it can be watched a bit more, because when it's too long, it can't be watched directly. So in the future, get on the Tevzi thing. I gave you the Discord link. Go there. I'm already posting technical advice there. I'll be posting more. There's also a lot of documentation and resources for free. I'll recommend the paid ones. I'll recommend the free ones. I'll recommend the paid ones at work from your company owner, if you have direct access to him. Your team leader, your manager, whoever. It's up to you to make a request. That's your thing. It's your thing. Your choice, or rather at your discretion. Okay, I approach the microphone. By the way, that's a very nice lapel microphone. I'm going to buy a lapel microphone, Amit. I haven't gotten it yet. It's a bit expensive, but I'll buy it. I'll buy it if it continues to be watched. Setup said, designs such as image processing on platforms like MATLAB and then do optimization, or do you start from scratch and write your own image processing algorithms? Now this Sadat is all about the company, that much, how much manpower they're putting into it. I've talked about this before. Ideally, one such complex algorithm, if you're going to implement, I don't think there's one programmer, one algorithmist, and one FBC guy. It's the best. I mean, in 14 years. And by the way, there has to be a validator. But I don't think verification. I've already by a separate team all the time. Well, I'm doing it. I'm admitting it. Okay, that's because the validator is always running testing. I'm just telling you that there are some problems that come up, and he gives you the thing. It's crashing. Here's where it fails. Fix this, and it comes back to you. But the algorithm, development of the algorithm. First, an algorithmist in MATLAB environment designs the algorithm in detail. Designs the algorithm. After that, he sends it to the FBC, the FBC guy, and between the algorithmist and the programmer, this is where it starts. It's a constant communication. And what part of that is, let's say the algorithm is a very complex algorithm, okay? Which part of that is going to be implemented in the software? Implemented in software will be implemented in FBC. Of it? Which part simplified? Those decisions is actively decided by these three people. Of course, the team leader of the programmer, the team leader of the programmer, the team leader of the algorithmist, and the FPC guy. The team leader also intervenes on some level, but the most, this is the best way. This is the best way. What if there are no resources? If you are, for example, in a startup, or then if you don't have an algorithmist, then you do that too. You open up, you do a literature review, and looking at articles. You test that algorithm yourself, test it a little bit in MATLAB, and then you pass it to FBC. But it's both parallel. At the end of the day, this product has a software interface. The communication with the outside world. You do that too sometimes. Then you do everything. But that's as it would normally happen. So these three, the basic elements plus a verifier. I mean, and by the way, for the software developer, there's a test developer. For the software developer. Well, it's getting bigger actually. In the big company, all of them, by the way, they're already, they do it at a certain level, but they sometimes, they don't see the big picture, even though they have so many resources, but some things don't go right. I talked a little bit about that today, but if you're on your own, you can make your own GUI in MATLAB if you need to. MATLAB has a GUI preparation interface. You just go to 422. It's safer because it's a differentiation. You take a 422, you take the chip, you take that out of the computer with the dialer. From the GUI, you connect the 422 line to your unit. Let's say it's a unit you designed, a small one. Let's say you made a camera, for example, okay? And it's got a gimbal and everything, it spins and stuff. I'm totally shaking it right now. And then you go and you send it commands from the computer. So you do the software interface. You write the algorithm in the FPGA. You write it. Some of it, again, that you use of the CPU, of the central processing unit. The quality of the CPU, you can still do some things, simple things on the CPU. Or you can use no CPU at all and just have an FPGA in the product, for example. You can communicate with it on 422. You can run your GUI on your computer, for example. But then it's not a direct, it's not a saleable product. I mean, anyway, they have a lot of things. Prototypes, there's a lot of different things, but it all depends on how much labor you have. Hello, sir. Hello, Hodja. Will we be able to say that at the end of your 28 trainings, will we be able to say that you will be Basic 60? Also, if we are interested in FPGA in professional life, how can we improve ourselves in this field? I've talked about this a little bit, actually. And I'd like it if you could write something. What if people who use nicknames like this write their name, for example, in parentheses? It can be Takmat, but Takmat should be the real name. For example, a friend of ours, I always call him Amit. I mean, he told me to call him Amit. I found out his name. It's not his real name, by the way. That's not important either. But I was just telling you. Not as Sanven John, but as, I don't know, Hassan. Then it's easier for me. And it's easier for you to realize that you have a problem. He said, which, I mean, of course, that a good foundation, a foundation like this, I'll try to give you the big picture as much as possible, but I'll also offer you, I'm going to offer you some training, like a very good one, Intel. There's Verilog tutorial on YouTube, 1 hour. I'll try to find it. What's it called? Anyway, I'll do that next week. VHDL system, Verilog comparison. I'll tell you what I know, free resources that I know, and of course you have to watch them. That's what it takes to be a good FPGA engineer. It's not something that happens in 28 lessons. I mean, I've been working for 14 years. I still don't call myself a great FPGA engineer. I mean, because there are much more awesome people. So, I think you're laying a solid foundation. But that doesn't make you a good FPGA engineer. A good FPGA engineer. You need experience. You need to work on projects. Team spirit is very important. Your friends are very important. It's very important. Brainstorming with them is very important. So there are too many parameters. Here is the demand for such trainings that you, what you know or don't know, even if it's just making a PowerPoint about it, and share it with your team. Because in that way, you learn a lot. I mean, I will share my experiences as much as I can. And now, how good an engineer, you get to a point where it's up to you. Now, wait a minute. Where am I? I'm lost. Sedat said, does it make sense to write communication IPs from scratch? Absolutely not. Definitely don't write them from scratch. Otherwise, as a sub IP, and use them as sub IPs and convert them to whatever we want. Because Ethernet is very complex, and I don't think I can write it. You write it, okay? You'll write it all down. Like, for example, Ethernet also has, you download the IEE document standard. It's not hard. If you don't have IEE access, you tell your team leader or the owner of the company at work yet, and he'll buy you an IEE Axle. You download it. And PCI Express, there's a company called Broadcast. You go on their website, yes, and they sell it for money. PCI 4, like 4.0 or PCI 5.0 standard. Okay, so it explains everything in there. You code it. Why it was made, why reinvent the wheel? Reuse as much as possible. And by reuse, well, what I mean by reuse, a company has already done better, and that your IP has already done better. Company, I can't give you the whole, all those IP-related reports, infrastructure. I've got it running. So encryption packaging, I'm selling it. Who says I wouldn't trust a company of 5 people, but I trust Broadcast. If I buy from Broadcast or Intel Xilinx, there are IPs that you can buy with money. I'm talking about soft IPs. And then there's hard IPs. They're already designed directly in the chip as a basic, designed right in the chip. It makes sense to buy them from the big companies. Makes sense. And there's also a lot of, when I say big companies, let's say, there are a lot of teams that do FPC design, software design. There are many teams. And this happens a lot, for example. A team on one campus, or what another team on the same campus designed, another team on the same campus designs it again. It's an incredible loss of labor because communication is inadequate. Okay, and the thing is, they know, and yet somebody's just standing up for their own things, Let's do it again. Or we could just call them, ridiculous things happen. I won't give you an example now. So what you're saying is that reusability is very important. If you have to take the money, pay for it and outsource it, or take it in-house and use it, makes a lot of sense. If there are some extras, if there's some extra requirements, maybe you can add that in at the next level if possible, without going into the design. But if you really have to, you can go into the design. So these decisions are already made by managers and team leaders. But to write something from scratch, and even reinvent the wheel, it's unbelievable. That's when it's happening. 20 years of FPC design. You're doing, okay. So a guy with 5 years is a much better engineer than you, because you're doing the same thing over and over again, You say, I made Ethernet. Bravo. What are you going to do? Everyone has done it so far. 250 people have already designed this IP. and when you designed it, must have added something. I mean, I designed something with a lot of bugs, I guess, because to make them bug-free. And they're, let's say, one Ethernet IP from one company. All right, 1 gigahertz, one Ethernet IP. And then it's TCP IP backed, not UDP, but I added something extra, 1 gigahertz with TCP IP support, Ethernet core, for example. Now you bought it from that company, but one person didn't design it. It was designed by 5 or 6 people. 5 or 6 people verified it. It went through a lot of regression. It went through a lot of tests. So there's an incredible amount of labor. So that money is usually worth it. Have someone design it from scratch. Have them verify it. You'll work for 10 years, I'll tell you that. And I'm still estimating whatever the cost of that IP is, not much more money than that. Your labor. That's why I told you, reusability. So what you're doing, you reuse as much as you can resources. This can be in-house. You can also outsource if the company has money. Most companies have money. What if, let me go in order for a second. Ahmed asked a question. I think that's it. I think that's the answer you got, Sadat. They call him principal. We're from there, Murat said. Principal, yes, principal is something used. It's a good expression. It's used. It's a good term, and if they give it its due, that's great. Some people also take these titles. For example, the guy is at architect, for example, but principal, for example, architect, for example. But, well, I mean, it doesn't help anything. There are a lot of people like that. It's not everything. You can be a thing, you can have great titles, but if you're not contributing something of value to the country, keep writing titles. Then he should just keep writing titles. What do you think about the synopsis? I don't know the synopsis. I don't know the details, but we've used synopsis for years. For example, Actel's synthesizer is always in synopsis back in the day. I don't know if they wrote their own compiler. I'm happy with it. I've never had any problems with synopsis. I think the SDC standard, very nice. You enter the constraints in a readable way. I mean, if there was anything better, it would have been passed already. In terms of design constraint, with a lot of Horizon, they've done something very futuristic. The file, they created a constraint file. For example, Xilinx used to have UCF. UCF. And that ISE is obsolete. It's gone. For example, nobody uses it now. Xilinx doesn't use it or anyone else. Because user constraint file, but its syntax wasn't that good, for example. Because SDC is so much better. When Xilinx came out with Vivado, they made a superset of it. It called it XDC, Xilinx Design Constraint. But it also supports SDC. Let me answer this one last thing. I'm pretty tired too, and it's getting long. He means the defense industry. It seems like there's a lot of this, let's write our own drivers attitude, he said. What if it's something simple like, of course they would, because after all, by the way, in recent years, in the last 5 to 10 years, a lot of things have been outsourced, also in the defense industry, but confidentiality, contracts, for example, the details of the IP, that company can't give out to anyone else. There are encrypted things and so on and so forth. So actually, that defense, in the defense industry, it's not like the old days, like we used to do everything ourselves. So it's easier in the civilian sector, but civilian defense, there's not as much trust as in the defense industry. Well, let me put it this way. In the civilian sector, for example, you go to company X. Do you have one? I do. How much? This much. Give it to me. Give it to me. Yes, I got it. But at what level was it verified? It's not very professional in the civilian sector. Okay. So for example, if I were to get the IP, I'm going to ask them for a file set that it's probably not going to happen. Okay. So I wouldn't take it from them because I know what reports they need to have, this universal coverage, where are the database files, what level of code coverage. I will ask for the documents of functional coverage. I will examine. So he's going to run. So he's going to run away, okay? Because these documents don't exist. That's why things are not easier in the civilian sector. In the defense industry, they want all these things. If they can't do some things themselves, also, they want it. because they're paying for it and taking it outside. For example, I've seen a couple companies, things. This IP, for example, when I was at Aselsan, I participated in critical design reviews, and after that, I participated in preliminary design reviews. We received the final product, we tested it, but because we demanded it, they did it very well. They learned a lot, for example, but in the civilian world, they themselves don't know that in the civilian sector, a man who has just started a startup, an experienced person, when he establishes a startup, of course he might want to, but I mean, I see he doesn't know much about the FPC business. There's money in it. There are many people who say, let's get in and start a startup. That's why I don't agree. It's easier in the civilian sector. In the civilian sector, everyone reviews everything and everything. It's not exactly like that, Amit. That job is a bit private, big, in private companies. You know, defense industry is a foundation company, but now they're private too. I mean, after all, from state facilities, nor did they give us passports. They didn't give us a passport or anything, or we couldn't get into state institutions at a discount. We were never civil servants, ever. It was always us. We were foundation company, private staff, private health insurance, and so on. Let me tell you, defense industry companies in general, from my own point of view, the work is of high quality. Well, they want quality work, even if they outsource it. Because there is awareness here, you know what I mean? That 30 or 40 years of experience, okay, I'm assigning know-how, like I said, such low level. Although the details of transistor level design are not conveyed, some things are, it's very well conveyed there. So don't think of it as inexperienced and stuff like that. I still have friends of mine who used to be my coworkers, and now they're managers, directors. So many people. Definitely don't go there. You know, there's a lot of civilians. Much more work is done in civilians. Over there, you know, there are no experienced personnel. That's just the way it is. I'm a bit beat up, so I might have done something at the end. Maybe slowed down my speech a little bit or something. Thank you. This is the first class. The next lecture, I'm just going to go straight in, so I'll just stay connected and cut. We had Q&A today, and the first week we did 2 of them together. That's what happened. You can join our Discord channel. You can like the video. You can recommend it to your friends. You know, the kind of tea and coffee conversation, or you can link to it now. You know, as long as we keep being watched. Like, let me see how many subscribers we have right now. 388, that's pretty good. 12 days, for something like 12 days, that's pretty good. And our total views is pretty good. 550 hours. So we're looking at today. And now, it will increase even more from now on. This way, we can share our experiences. A more conscious generation, a more loves FPC, knows FPC, and an engineer who can focus on the big picture. A community of engineers. To actually cultivate a community of engineers is my main motivation. The more I can contribute. But of course, it's your team leaders and your managers, because if they allow you to do things, or if they support you, I'll talk, I'll stand here, I'll be fine. But this consciousness is spreading, let me tell you. When I talk to new engineers now, compared to 10 years ago, when I talk to new engineers, they immediately ask me, what should we do? Here, in the long run, how about this? For example, he asks about EHLS. Is there a future in EHLS? Is there a future in AI? Is there a future in FBC? For example, they say. AI, for example, taking software developers' jobs. The possibility, I think, that in another decade or so, the work of software engineers, because, again, it's very subtle, touches and all that. It's not that possible for AI to do that. But for FBC, to go to the lab and test it like this, doing simulations, long-lasting verifications and so on, for example, for FPC, I don't see that risk at all. That's why I recommend it for people who like it. Or, you know, I try to make them like it. I think it's very enjoyable. So I can guarantee you that. Both designing, verifying, testing. I can guarantee you all. Thank you. I wish you success. Have a good Sunday. Take care of yourselves.